A very good morning to our beloved and respected lecturer. Today, we are going to present about paraboloid structure on slope of surface. And I'm from group 5. This is our topic for our engineering maths project. Okay, so our group consists of 5 members. And firstly, Shavinash, which is me, Valentine, Siti Nur Aisha, Amira Akila, and Siti Nur Shazwana. So these are all my group mates. And before we get into the deeper part of paraboloid structure over a slope of surface, we have to get the main idea or the concept of slope. So let's take a look at the introduction. The estimation and calculation of researching the inclination and declination over a hill has always been the focus of engineers if a bridge or road or a railway track is being built over a hill. The inclination and declination of the railway track or bridge or road over a hill is known as a slope. So that inclination and declination is known as a slope. So the main concept of slope is the steeper the surface of a hill, the greater the slope surface. So this is the main concept, the main idea. The measurement of slope is usually obtained by calculating the tangent of the hill surface or any inclining or declining surface. So to get the measurement of slope, we have to calculate the tangent. How the tangent is calculated. So let's take a look at the third point. It's by using a simple criterion, which is dividing the vertical change in elevation by the horizontal distance. Then the slope surface is obtained by differentiating function of two variables. When working with a single variable, differentiation is used to get the slope of a curve. Okay, and meanwhile, the slope of the surface, which is function of two variables, may be assessed in two directions. And the direction is called as something very common and everyone has heard of it, x and y. So the slope of the surface in the x direction is called fx, while the slope of the surface in the y direction is called fy. So let's take a look at the problem statement. What are we going to overcome? So first we have to know the problem. At the paraboloid hill area, a team of specialized structural engineers conducts a field assessment in preparation for the construction of a rail bridge. To prevent exceeding the speed restriction throughout the bridge, they must consider the slope of the surface when constructing it. The hill's peak height is 30 meters, its width is 10 meters, and its center value is 5 meters at a height of 10 meters. So this is basically the problem we are going to overcome. This is our main backbone and structure of our project. Thank you.
I will continue the presentation for the solution. For the solution, the first thing is to develop the fila table. The first fact is bridge with parabolic curve at parabolic hill area. From this fact, we can find the idea for this problem is to need a parabolic equation. The learning issue that we can learn from this idea is how to determine the equation. The action that we can take from this idea is we create an equation from height of parabolic bridge, which is 10 meter and 10 meter width with the center value of 5 meter using equation y equal to negative a x minus h to the power of 2 plus k. The second fact is bridge as a slope of surface when it's contact with the ground surface. The idea from this fact is for x direction and y direction need to find the slope at certain point. The learning issue that we can learn from this idea is how to determine the specific coordinate. The action that we can take from this idea is we can find the dilation factor, which is a, to apply at the equation of parabolic bridge by using vertex point, which is 0, 30 and 0.512. This point we can get from the width of the bridge from the center, which is 5 meter, and height of bridge, which is 10 meter. The last fact that we have based on the problem is illustration of a surface in the first octane and the slope of the bridge. The idea that we can take based on the fact is illustrate the surface in the first octane and its slope. The learning issue that we can learn based on the idea is how to determine the first octane and its slope. The action that we can take is we use the equation of parabolic bridge based on the equation that we get from the first action, and using the point 512 we apply the formula of partial derivative to find the slope of surface in the x direction and y direction. Next, I'll pass the presentation to Aisha.
This is our diagram of the project, and this is the graph for paraboloid of railway track.
For the calculation, step 1, we have to determine the equation of paraboloid from the value of vertex, which is turning point. So from the graph, we know that turning point or vertex point is at 0 and 30. So to find the equation of for railway, so we already know that y equal to negative a x minus h square plus k. So we already know that h and k value, which is 0 and 30. So substitute the 0 and 30 values inside the equation. But we don't know the a value. So to find the a value, from the graph, we know that the curve at 0.5 and 12. So x equal to 5 and y equal to 12. Substitute the value of x and y into the equations. So we know we could find that a equal to 18 over 25. So put the a value inside the equation. So we know that equation of paraboloid railway is y equal to negative 18 over 25 x squared plus 30. So for step 2, we have to find the slope of surface using partial derivative. So slope in x direction from the function of fxy, we get that negative 18 over 25 x squared minus y plus 30. So by using the partial derivative, we get that fx equal to negative 36 over 25x. So we have to substitute of x and y value into the function. Then you will get that function equal the function of x equal to negative 7.2. So the slope at 0.5 and 12 is negative 7.2 in the direction of x. So for slope in y direction, from the function of that we used earlier, we get that negative 18 over 25 x squared minus y plus 30. So we know that fy equal to negative 1. So at 0.5 and 12, just substitute into the function, then you will get that fy equal to negative 1. So the slope at 0.5 and 12 is negative 1 in the direction of y.
So let's see the result. We illustrate the slope of surface in the first octane. Assume z equal to negative 18 over 25 x squared plus 30. On the xy plane, z is equal to 0. So we substitute z equal to 0 to the equation. So we got 80 over 25 x squared plus y equal to 30. So if x equal to 0, we substitute in the equation that we get. So we got y equal to 30. And then if y equal to 0, we substitute in the equation. So we got x equal to 6.45.
Good day, my name is Valentin Mapanana Jalan, matrix number AF210092. Today I will talk about the conclusion for our group project. To sum up, the application of slope is frequently used to determine the slope such as in railway tracks, hills, and other applications. In our project, the equation used is generated based on parabolic hills, height, and width. So, the slope in x direction is much safer to conclude compared to y direction due to the value of x is smaller than the value of y. This is because any U-shaped curve cannot be considered as a parabola in reality, since every point on this curve must be equidistant between the directrix and the focus. Hence, when we apply the parabola equation, We receive a higher chance for an inaccurate numbers since the surface of paraboloid hills is not completely U-shaped, resulting in a higher likelihood of unequally spaced points on the curve. That is all from our group. Thank you.